now Sunil sir is muted and we can start our discussion. Is that okay? Hello.
Yes, sir. Yes, sir.
Okay. Yes. So good morning to all of you. Uh, is that
Morning, sir.
morning? Is that PPT is visible to everybody?
Yes, sir.
Yes, sir.
Yes. So today, what we need to do today, I have a very good topic for you, as well as there is some assignment also for you, and you need to prepare those topic in this particular week, and you need to present to all of us such type of the stuff we have. And first, we will start with the brief overview about our previous lecture, and what we have done and what are the stuff that we have discussed. So, can anybody start their mic and tell me what we have done in the last lecture? So, topic is there like telephone network and cable
Sir,
TV network. Yes.
background થી અવાજ આવતો હોય.
Hello. Now it is audible or extra voice is there?
સર
Hello.
જાણે માઇક ન હલતો હોય એવો અવાજ આવે.
Mic.
Yes, sir.
Uh, now it is okay because I have connected headphones so to hear properly. That's why. Now it is okay with mic. Hello.
સર હજી
એટલે
હજી
આ
આવે.
થાય છે શું actually?
એટલે માઇક જાણે એમ ન હલતો હોય પવન લાગતો હોય હવા ન લાગે.
Okay, પવન લાગે છે. So તમે મને ગરમીમાં બેસાડશો.
કચકચ થાય છે સર, કચકચ થાય થોડું થોડું.
Hello, is that okay? Hello. Now is that okay?
યસ સર.
Everyone? Hello. Is that audible?
Yes, sir. Yes, sir.
Okay. Now it is there and any extra thing or we can start?
Yes, sir.
Okay. So can anybody tell me what are the stuff that we have discussed in the last lecture on this particular topic so we can start with that one?
Yes, sir.
Yes. So tell Rageshwari what we have discussed in the last lecture.
So बहुत सारे टॉपिक डिस्कस किए थे. We started with multi-stage switch. Then we went to time slot interchange. Then switching in LATA. Then
Okay.
point of preferences.
Point of
Then
references? POP?
yeah.
Okay. Yes. Good.
Then we went to telephone line bandwidth. We saw the different bandwidth. Then
Okay.
we discussed layered in SS7
Okay.
and modulation, demodulation,
Okay. We have
discrete
discussed about the
technique.
modem. Yes. Modem we have discussed.
Then cable networks. Yes.
Okay. So such type of the stuff we have discussed about the modem, about the telephone network, how it is going to be performed, and what are the bandwidth allocation are there. Okay, what are the SS7 layer? The brief about the SS7 and such stuff we have discussed. We have discussed about some of the example of the telephone network, how it is exchange is going to be work. What do you mean by time domain switch? What is a space domain switch? What is a combination of time, space, time switch? Such type of the topic we have discussed in the last lecture. And the topic which is remaining in that particular chapter in telephonic network and cable network, which is a cable network for data transmission. So today we are going to discuss about the cable network and how it is going to be work and what are the different aspects of that. So let's start with that cable TV network, which is started initially as a video service, and mostly it is nowadays we are familiar with that cable TV network. It means it is a video service provider. Okay, and it is moved from the business of internet access. Now cable TV network nowadays also provide internet access services also. So we can say we are going to discuss in that if you are having a video service provider, how they will accommodate internet service provider or internet servicing also. Okay, so such type of the stuff we need to discuss in this particular cable TV network topic. So we need to discuss about what is a traditional cable networks, what are the hybrid fiber coaxial network, and how it will give you the distribution, or how it will distribute the internet service also, and how it will distribute the video service also. So such type of the topic we are going to discuss in the cable TV networks. This is a basic traditional cable TV network, and all of you I think aware about that. There are the one particular office are there. We can say that that's the previous kind of the cable TV network. Right now we have totally shifted to the digital subscriber as a DTH service, direct to home service. But this is about the previously available cable TV network, and lots of companies are there. DAN are there, GTPL are there. They are still providing in Rajkot with this cable TV network. So what they have one particular big office is there, and at that particular office they have the pickup antenna. So that picking antenna, what it will do, it will first of all capture the packet of several channels from the satellite, and whatever the band is allocated to that particular big size of the antenna, and from that it is getting the channels of variety, like from the sub, from the star, or from the different kind of the bunch of the service provider or channel provider, we can say. So from that particular kind of the office, they are having the head end, we can say, like head end, it's having a combination of all the channel. Like what is going to happen over here, it will combine all the channels, okay, whatever the star, Z, whatever the stuff is there, it will combine all the channel and it will give it to one particular coaxial cable. And that coaxial cable now going to propagate to the entire region, and there is an amplifier is there, intermediate, there is amplifier is there, and which is connected with the coaxial cable. So in coaxial cable, all the UHF, VHF band of the channel is going to be merged, it's multiplex, and it is given to the one particular coaxial cable. And coaxial cable is having intermediate amplifier that to boost their particular strength. And there is a splitter are there, like splitter, which is nothing but there is a small device are there which will divide the power. Like if one connection is there in this society, another two connection are there in another society, so they are just splitting the power. And likewise there is a drop cable are there. Drop cable are nothing but there is a tap cable are there which is given to your cable TV or from your particular TV set. So such type of the setup mostly working on the coaxial cable, having amplifier and working as an analog communication. So such type of the basic distribution network is there from the picking antenna, lab kind of the head end to your particular home. Such type of the connection is established by the cable TV network. Like communication in the cable TV network is going to be unidirectional. It's a broadcasting service. So you cannot say your view or your opinion, or we can say your service, you cannot provide from your TV set. It's a one directional, unidirectional service is there. You just need to listen. Another stuff we have, like for the high speed, or if that now let's take consider that if HD is introduced. Now if there is a HD is introduced, and let's take it required a very high bandwidth. So whatever the existing band is available in VHF and UHF band, and which is carried out by the coaxial cable, it is going to be happen like that. This band is not sufficient over there. So what it's going to be happen like this same cable TV network, now distribution is going to be done through the fiber optic cable. So they are having a bi-directional fiber optic amplifier is there. And in this fiber optic cable, that from the distribution hub to the individual kind of the fiber node, it is situated with the optical fiber. And after that, from optical fiber to coaxial cable, so optical to electrical converter, such type of the intermediate devices there, which will give the actually the channel into the coaxial cable to your end. So what is a difference between hybrid fiber coaxial, that up to the distribution node, the connection is going to be done through the fiber optic cable, and that intermediate device is also related to the fiber optic. Okay, that's the only difference between conventional and the fiber coaxial based network. So communication in HFC cable TV network can be bidirectional. So whenever there is a query, or we can say, if we can say there is some type of the service, if you want to access, such type of the stuff might be handled in the fiber optic network. Now, if I'll give you the example of the current scenario, like all the cable TV network, also they will give you one set-top box. If you are aware about that, they will also give you the set-top box. Now, in previous, what has happened before 3 to 4 years or before to that, like directly coaxial cable is connected to your television set. But now they have put one intermediate set-top box. That set-top box having the data of the subscriber ID are there, the channel that you have subscribed, or if there is any special channel if you want to access. So according to that, they will give you such type of the services. So to provide such services, it required a bi-directional communication. So it's going to be possible, like if you are using such a fiber optic network, or if you are using such type of the services, so bi-directional type of the process, it must be incorporated with the existing system. So channel network is going to be as it is. It's a GTPL itself, DAN itself, but now they are moving towards the digital. So that's why they have having the process of kind of the fiber. It's going to be connected over that particular intermediate. Now, another technique, like that's about the video transmission or for the broadcasting. Now, how the data transfer is going to be possible? So GTPL and that particular company also provide, along with your cable TV network, along they will also provide a data network also. So how they are giving this particular stuff? They are competing with the telephone companies for the residential customer who wants the high-speed data transfer through the same established network. So what are the stuff are there? Like whenever there is a coaxial cable is there for the video transmission, they are having a similar type of the stuff. Like they are having one dedicated band for the video, as well as a dedicated band for the data downstream, data upstream. So along with the 5 megahertz to 750 megahertz, they will provide all the three stuff: video broadcasting also and data streaming also. So what they are doing, they are combining your video and the data along with the same cable by using a different multiplexer and such type of the devices. So you can access the internet also through the same coaxial cable. So what are the different devices are for that we are going to discuss just after this particular slide. So we can say downstream is going to be modulated with the 16 QAM modulation technique. Can anybody tell me what do you mean by 16 QAM modulation technique? You just need to speak voluntary before I'll ask to any particular person, like you speak. Okay, anybody voluntary can give the answer. Right or wrong doesn't matter, but plus give the answer. What do you mean by 16 QAM? What do you understand from 16 QAM modulation technique? What is your thought on that? Or now let me ask to one particular person. Yes, Viren. Yes, Viren. BMW. Yes, Viren. Viren Vadodariya. Am I audible to you? Yes, Viren. What do you understand about 64 QAM modulation technique? What is your understanding in this? (64 QAM), Viren. Yaswant, also you need to think on that. I'm coming to you just after the Viren.
Sir, both કે ખ્યાલ નથી પણ
Whatever.
higher order modulation technique છે.
Higher order modulation technique. Okay, Yaswant, what is your thought on 64 QAM technique? Yaswant Chotia.
Yes, sir.
Tell me, what is your thought on 16 QAM modulation technique? 64 QAM modulation technique.
So 4 beats per symbol.
4 beats per symbol. Rahul, what do you say? Rahul. Rahul, eh?
Yes, sir. Yes,
Yes.
sir. Yes, sir.
What do you understand about 64 QAM? What do you mean by 64 QAM technique?
It is a dense modulating technique, sir, which has 6 groups of 12 bits.
6 group of
12 bits.
Okay, 6 group, or we can say there is a 6 beats are there.
Beat.
Okay, 6 beats are there. Oh, okay, 6 bits are there. So we can say each and every particular data is combining on 6 group of the bit, and then it's going to be transmitted. So again, in the same inline of the question, if I'll go to the Bijraj, yes, can you tell me, Bijraj, if I'm having a 6 bit of the group of the data, can you tell me how many voltage level we require? Bijraj. Bijraj. If while asking the question, you are muted. Okay, please, everybody speak. Je avde, kai khotu sachu je hoye to પણ બોલો ખરા કઈ. If I am having a 6 bit of the data which is represented each and every symbol, how many voltage level I require? We have discussed this several times. Ahmad. Ahmad. Ahmad.
Yes, sir.
Hello, Ahmad. Tell me, if I am having a 6 bit of the data.
Hello.
Yes, hello, Ahmad. Am I audible? Ahmad?
Yes, sir. Yes, sir.
Yes. So if I am having a 6 bit of the
Yes, sir.
data,
Yes, sir. Yes, sir.
how many voltage level I required in QAM?
In QM.
First of all, do you know voltage levels, number of levels?
Yes, sir, I know.
You know, so just tell me, how many voltage
Sir, I think
levels?
16.
16. So if there is a 16
I think
voltage
16.
level required, so how many bit per level? It's a 4. 4, 2 raised to 4, 16. So if we are having a 4 bit of data, then there is a 16. But if I am having a 6 bit of data, then how many level?
64.
64, yes, obviously 64 QAM, it means
I just
64 voltage level. Okay. Can Bhavik Chawda? Hello?
Yes, sir.
Bhavik, can you tell what is the constellation diagram for the 16 for QAM, or what constellation diagram will tell us? You can also say about the constellation diagram. What you can get the idea from constellation diagram?
No idea.
No idea.
Hello, sir.
Yes, Kalpesh. Yes, Kalpesh. Speak.
Sir, 90 degree ની તો ઈ કયો તમે સર?
Yes. What you can get the information from constellation diagram?
હા તો સર એક 90 ડિગ્રી ની અંદર જાણે કે 16 હોય તો એમાં 4 બીટ હોય અને 64 નું તો એક 90 ડિગ્રી માં 6 હોય છે.
Okay. Any other answer? Yes, near to that answer, like it having some degree wise, some allocation is there. Any further answer? Proper answer I required. Khushbu, can you tell us what constellation diagram will tell us? If I am having a 16 for QAM is there, so how many points are there in constellation diagram?
No, sir.
No? Any other student? Any other? Please. Jason will give answer. Jason? Okay. So let me give the answer. So here there is a 64 QAM. It means it is having a 64 voltage levels are there. Each voltage level will represent with the 6 bit, and in the constellation diagram there is a 64 dots are there which will represent the different angle and different amplitude for the different voltage level representation. So 16 QAM, it means in constellation diagram 64 points are there. And what constellation diagram will tell us? Like each and every level out of the 64 levels, each and every level is represented with how much voltage, or we can say with how much amplitude and with which particular degree of the modulation that signal, like which particular degree it will take from the carrier frequency and at which amplitude. So that all stuff quantity you can get it from 16 QAM modulation technique. So theoretically, downstream of the data is 30 Mbps, and QAM is applied in kind of the downstream data also. And we can say that upstream, which is going to be using as a QPSK. Okay. So there are the two modulation technique used, and its upstream is going to be 12 Mbps speed. That's a kind of the simple specification of the upstream and downstream. What is going to be happen at the cable TV? Like it's similar as a telephone network. In cable TV also there is a modem is there, so that's considered as a cable modem. In cable modem we are having a filter is there. Like it's simply we are having a three filter: one filter for video, one filter for the data upstream downstream. So by applying the filter, you can distinguish the video separate and the data separate, and then it is passed through the cable modem, and you can again get the data in your particular PC. Can anybody tell me why cable modem is required over here to get the data? Why cable modem will required over here to get the data? Cable modem over here required to get the data because whatever the signal coming from the filter, it's still in an analog. So analog directly feed it to the television set, but analog not going to be fed to your computer. It must be converted from analog to digital, so that cable modem will do that task to conversion from analog to digital. If we can say there is a fiber transmission is there, so similar type of the thing is happen from the particular header. We can say from the head end, video is going to be there, and from the internet, that which is another kind of the network which is connected through your cable TV network. So it's give you the bidirectional data, and then it is going to be come to the CMTS, which one of the type of the modem we can say. Then it is passed through the combiner, where the video and data both going to be combined in analog in manner, and then it is fed to the fiber. Okay, so before to that fiber combiner will also it is also going to be do the task of analog to optical conversion or electrical to optical conversion. This is a cable modem transmission system we have. So we can say this is a stuff we have right now: cable modem transmission system and cable TV network. How it is going to be give you the data through the cable TV network, and such type of the stuff we have. Okay. So is there any doubt till now? Is there any doubt till now? Anybody having the doubt till now? Any doubt over here? So I will move forward to the next chapter, and that next chapter, first I will explain about the basic stuff that we need to discuss, and then I will give the task to individual student, and in the individual student need to prepare that topic, and you need to present back in the lecture or whenever the topic I will allocate it to you. So what are the stuff we have, like error detection and correction? So if you can start with that, like data is going to be corrupted during the transmission. Are you agree with that or not? Data is going to be corrupted or not during the transmission?
Yes, sir.
Yes, sir.
Okay. Why we can say it's going to be corrupted? What are the stuff we have due to that data is going to be corrupted? Yes.
Noise
Speak up.
attenuation.
Answer. I required answer. Why we can say it's going to corrupt it? Yes, we can say noise are there, attenuation are there. There are the several factors are there. Due to that, data might be corrupted. So we can say some application that required the error to be detected and corrected. Like in noisy channel, we are always sending data in noisy channel. So it's always there. Data going to be loose or data going to be corrupted. So we need to put such type of the mechanism from which we can again retrieve those data which is going to be corrupted during the transmission. So that is our requirement over here. Like what are these techniques are there through which we can detect the error and we can correct it also. That's the overall topic of discussion we have. So for that, we will discuss first of all, there is some of the issue directly, indirectly to the error detection and correction. So topic are there, what are the different type of the errors are there? What do you mean by redundancy are there? What is the detection versus correction, forward error correction, coding, and that's different modulator, arithmetic techniques are there. So in that, in single bit error, only one bit in the data unit has changed. Like if we are using a digital signal, So it's going to be easy to identify if there is a correction, if there is a error. So might be it is changing from 1 to 0 or 0 to 1. So we can say only one bit changes there. So we can say whenever we are saying it's a single bit error, it means either 1 change to 0 or 0 change to 1. That is a simple technique, or we can say simple understanding for us. Like in 1 bit data change, only single bit is changed. This is an example of that. What do you mean by single bit error? Previously you have sent the 0, but it is changed to 1 due to the any noise or due to the any kind of the problem. It's changed from 0 to 1. That's, we can say, single bit error. So we can say burst error. It means 2 or more than 2 bits is going to be it's going to be changed. Then we can say it's going to be a burst error. So single bit error and burst error. Burst error, it means more than 2 bits, 2 or more than 2 bits, while single bit, only single bit is going to be corrupted. This is the example of the burst error. Like in the length of the 8 bit, there is a 4 bit is going to be changed from 0 to 1. So we can say this is a burst error we have. So we need to think about that. If we are having a single bit error, what are the techniques are there to detect and correct? And if there is a burst error there, burst errors are there, then what are the techniques to getting that detected and to correct it? That's our overall requirement of this particular discussion about the error correction and detection. Now to detect or correct the error, we need to send the extra bit, which is named as a redundant bit. So we can say if you are sending an 8 bit at a time, but to getting this error detected or to correct those errors, we require to add an extra bit in your actual data to identify the error in that. Now this is also the controversy over here, that whatever the extra bit we are sending, if itself get corrected or if it itself get kind of the change, then what happens? So that's are the another issue is there. But to getting the error detected, we need to add the extra bit in our particular system to identify where the error is there or where the error need to corrected. That type of the stuff we are having in terms of error correction and detection, while the extra bit known as a redundant bit. So this is a one particular diagram of that. While we can say there is a sender are there, some of the message are there, and depend on the message, it will generate some type of the code out of that. That code is related to that message, and which is going to be add with your actual message. We can say it's message and redundancy bit, and combinedly this particular bunch of the data will send it to the unreliable transmission or noisy transmission. And at the decoder side, what is the stuff is going to be there? It will receive the entire packet of this data along with the message and redundant bit. Then it will check. Okay, depend on that particular extra bit and actual data, it will check and it will identify whether this data is corrected or not corrected. So if it is correct, then if it is data is going to be okay, not any particular issues are there, all the bits are received successfully, then it is giving to the higher order or to the higher level. We can say that data is correct, or it will discard from their particular level, like this is having a errors are there, so I will not accept the data. Such type of the process happen in encoding and decoding stage of this particular process. So what we are going to be stuff in this particular stuff in this book, we concentrate on block code. We will leave the convolution code to advance the text, or we can say we are adding the extra codes are there, which will actually we are adding to identify the error or to identify the error or problems in that. Another stuff we have in modulo n arithmetic, we use only a integer in the range of 0 to n minus 1 inclusive. Or this stuff you are going to understand in terms of the how much bit is going to be detected. According to that, how much bit you can correct it. Like if we can say if you are able to detect a 2-bit error, but actually n minus 1, so 2 minus 1, 1 bit you can correct it. Such type of the stuff is there in every block code. Like if you can detect a 3-bit, but you can actually correct only 2-bit out of that. Such type of the algorithm is always going to be there in the data communication and networking. For that, initially, there is a simple process is there. We can say XORing. So if you are XORing the 2 particular bit, we can identify whether in terms of 0 or 1. So we can say, let's consider this example like this is a truth table of the XOR, nothing but. If you are having a 2 same bit, we can say you are getting 0. If 2 different bit, then we are getting a 1. That is a simple. So if you are having a bunch of data of 5 bit and another bunch of data which is another 5 bit, so if you are doing a XORing of that, actually you can identify that which particular bit is changed. Let's consider this is your transmitted bit, this is your received bit. If you are simply doing a XORing of that, you can identify which bit is changed. Now if that no bit is going to be changed and it's received as it is, then all the zeros coming over here. But if something is going to be changed from 0 to 1, you can detect those particular error over here. Like this bit is changed, this bit is going to be changed. Are you getting my point? Is there any doubt or is there any problem in the concept, like what we are doing and what we are discussing? Any doubt, any question? Any doubt? Please speak up.
No, sir.
Okay, so this is a simple stuff, like we need to add such type of the algorithm which can actually identify what is the errors are there. First we need to detect, then we need to correct. Now this is that's the stuff I have discussed up to this particular point. Like this stuff we are going to discuss now. Whatever the topic are there, this is some of the topic, and some of the topic you have already learned in the data communication and networking. NK type of the linear block code, CRC code, checksum and parity also you have discussed might be, but checksum and parity might be new, but it is so much easy. Like if you can go with this PPT, or if you can go with that material that I have suggested you from the Tata McGraw-Hill website, you can get the idea about this one. So what I'm doing right now, there is a 4 topic are there in this particular error correction and detection, which is a block coding, CRC coding, checksum coding, and parity check coding. So you need to give me your enrollment number to prepare the any one of the topic out of that. Or I will give the random over here. So block coding, we will take the block. It's a random and everybody need to take one topic at least. So whatever the topic you need to take, you need to prepare little bit amount of the explanation, about 2 to 3 slide or about the proper page in terms of written, and you need to explain to entire class in the next lecture onwards. Okay, I will give a 2 to 3 lecture to prepare, don't worry. We will start this exercise from the next week onwards, but you have the enough time to prepare for that.
Sir, PPT બનાવવાની છે?
You can choose anything. Either you can choose PPT, or you can choose any particular website, or you can choose any particular written material, whatever you will want. It's up to you. PPT, it's very good. Another stuff also going to be very good. Animation, very good, but it's flexible. Whatever the stuff, but it should be, we can say it's explained itself. Like whenever you are giving this slide, everybody can explain it proper. It's understand properly. Yes. So anybody, please start with the number. We will take the block code.
So 11.
11 block code. Yes. Then.
Sir.
Yes, speak up the number
13.
or topic. Huh?
13.
13. Block code 13. Any other topic also you can speak. Okay. CRC, not it's up to the block coding. You can speak like that. My number in CRC. Yes.
3.
3 in CRC.
Block માં કેટલા એટલે એકમાં કેટલા હોય?
Whatever, like every topic should be covered by everyone. Okay, so it's not like that. सबने 3 topic ले लिए, फिर कोई नहीं, ऐसा नहीं. Yes, checksum कौन करेगा? चलिए.
Sir, I will do checksum.
Number?
Sir, 10 in 15 series.
10 in 15 series. Okay, James, I will write J-A-I. James, चलो, James लिख लेता हूँ.
सर मारो नाम दे दो ना साथे.
Number? Kalpesh.
Kalpesh लखी लो.
Kalpesh, yes. Yes, next. Quickly. Parity is pending. Everybody need to take one topic, okay? Not like that. इन लोगों ने ले लिया, बात खत्म हो गई.
17, sir.
6 parity.
17 in parity checking. Okay.
6, sir.
Huh?
6 parity માં.
Number 5. Okay.
6, sir.
Two, sir.
What? Or what I will do? I will just give this particular name. You need to write down your enrollment number in front of the name in chat box. Okay. Let me go to the chat box. This is the topic, and you need to write down your enrollment number in front of the any one of the topic. Is that okay? So write down that enrollment number in front of that particular topic, and then you need to send it over here so I can get the idea for that. And that is considered as your attendance today. Not taking at this particular moment, but it's considered as attendance. Rajkumar, which topic you are taking?
Parity.
Okay, so write down your name and your enrollment number and the topic quickly. So please mute your mic, and meanwhile you will write it down this particular topic, and that is only considered as attendance. And now we will move forward for the next topic, which is actually a data link control. Yes. Any doubt, please speak up. Yes.
CRC.
What CRC? Oh, okay. Whatever the topic, you just write it down in the chat box. Write it down in the chat box and leave the your topic over there. I can find it out from that particular. Is there any
Hello,
doubt
sir.
till now? Yes.
Sir, these four.
Just a second. Yes.
Sir, these four techniques are only method to solve encoding and decoding, or any other coding.
No, it's like that's technique are for identifying the error from the data and generating extra bits to detect the error and to correct the error. So that are the encoding and decoding technique. That's both are encoding and decoding technique. It's not like just an encoding technique. That is encoding as well as the decoding technique, but their task is to identify the error and to detect the error. That's this. It's not like the decoding technique alag hogi, encoding. No. Encoding, if you are doing encoding with the parity, then decoding also going to be done with the parity.
Okay, sir.
You getting my point?
Sir, okay, sir.
Yeah. Okay. Any other doubt? Please. Okay, so if we can go with the new chapter, let me just give the brief about that. Then we will leave off that particular overview of this particular chapter and what we are going to discuss in the next particular lecture. So in the next lecture, we are going to discuss brief on the data link control. And what do you mean by data link control? Like it's related to the data link layer. And we are adding some of the extra bit, and we are creating a framing structure in such a manner that we can effectively send the packet from sender to receiver. And if packet is not received over there, then what are the process are there to getting that packet back? Such type of this stuff we are going to discuss in this particular chapter. Moreover, it's going to be discussed as a how frame is going to be made and how it is going to be transmitted. So if you can say that's those who have the mic on now, please mute the mic so it will not create a disturbance. So what are the stuff over here? Like in the frame, actually whatever the data is there, the data is going to be situated at the middle of this particular encapsulation. While it is having some of the header is there, trailer is there, as well as there is a flag beat are there. So there are some specific beats are there, or some specific identification is there for the particular data which is coming from the upper layer. Okay. So at the data link control, such extra padding of the beats is going to be added to get the information about their ID, to getting the information about their error and correction and detection and all stuff. It will also give the information about the packet starting, packet ending. For that, flag is going to be added over there. So such type of the extra bit is added at the data link control for the several process and for the several particular kind of the identification of the packet, okay, for that different techniques. So what is going to be happen? Be byte stuffing and unstuffing kind of the thing we have. Like first of all, why we are required a byte stuffing and unstuffing. So for that we are having a situation like that. Let's consider we have choose one particular beat of sequence in the flag. Let's take we have choose a 6-1 which is assigned as a flag beat. Okay, so every packet which is passing through the data link layer, it always added a 6 beat of the ones at the beginning of the sample, at the beginning of the data, and at the ending of the data. Now it might be happen that in data also such type of the flag related to the bunch of the data coming over there. It's repeated. So please unmute your mic. Who has kind of the mic is Tahir? Please mute your mic. Please. Yes, thank you. So what are the stuff over here? Like whenever there is a flag, so similar type of the beat of the flag is coming in your data. So to differentiate from flag to the actual data, extra byte is going to be added in the as a stuffing of the process. So if in your particular data, if there is a similar type of the data of the flag will come, so it is encapsulated or it's going to be stuffed with the extra byte as a escape. So one particular character is going to be added to differentiate from flag to the data. While when we are receiving, so at the receiving side also they are having the decoding algorithm is there which will identify like if there is a escape coming, it means it's a repeating data in the entire packet. So I need to remove that escape and I need to get the unstuffed data which actually is transmitted at the transmitter side. Is there any doubt in this particular PPT, what I have discussed and what are the stuff I have explained to you?
Sir, can you repeat one time?
Okay, so it's going to be happen like that. Like when first we have decided, just for example, we have decided at the data link layer some of the flag we are adding. Now flag is nothing but one set of data sequence is there. Let's take 6 times 1. 6 times 1 is a beat sequence which is denoted as a flag. So whenever you will see 6 times 1, it means it will notify you that now the data is started. Okay, now actually the packet is or frame is started. Now if it is happened like that, similar type of the beat pattern also repeating in your data also. So तो क्या होगा इधर कि like आप flag में भी 6 beat of data कह रहे हो और यहाँ पे flag आया तो क्या ये identify करेगा? Like this flag is starting over here and frame is ending over here, but actually frame is ended over here with the another flag. So to prevent from the cutting or to prevent from that breaking of this particular frame due to the similar type of the data which is matching with the flag data, you are adding an extra beat over there. यहाँ पे भी 6 times 1 आ रहा है और डेटा में भी 6 times 1 आ रहा है, तो आप कैसे डिफरेंशिएट करोगे दोनों को? To adding the extra beat over here, you can differentiate both of them, and during the encoding process you are adding this extra escape byte, and at the receiving side, decoding side, you are again adding this escape beat, and it's going to be getting that data back at the receiver side. Is that okay, or is there still any doubt?
Okay, sir.
Okay. So we can say byte stuffing is the process of adding one extra byte whenever there is a flag or escape character in the text. Okay, if it is going to be matched with the data, so it's an extra character we need to put. So this is an example like that. There is a frame, such type of the flag is there. 0 is there, then 6 times 1 is there, then 0. So this is a flag at the starting and at the ending of the particular frame, while some of the header, trailer, and actual data is there. Now this is going to be happen like that, similar type of the data coming over here also. So we can say beat stuffing is the process of adding one extra 0 whenever there is the 5 consecutive ones followed a 0 in the data, so that the receiver does not mistake the pattern of this flag. Okay, so what is the meaning of that? You can understand from this particular diagram. So it will show that we are having a flag which is nothing but, what is a flag we have? 0, 6 times 1, and then 0. So if such type of the data coming over here also, 0, 6 times 1, 7 times 1, so we can say it is misconcept over here. So what we are doing, after the 5 times 0, you are adding one extra 0 stuff over here. Okay, so now it is going to be differentiate, like it is not matched with the flag beat, and you can identify the separate, and the actual data is going to be transmitted after this stuff. So whenever it will receive over here, like over here, there is another 0 of 5 times 1, and then again 0 is there. So it's going to be added the extra 0 over here also. So at the received side, it will remove that extra 0, and actual data you can get it back from the decoding process. So this is called as a bit stuffing. So instead of byte, if you are adding an individual bit, then it is considered as a bit stuffing. So two stuff we have, bit stuffing and byte stuffing. So in exam, they will ask you the question like that, what is difference between bit stuffing and byte stuffing? So this two diagram you need to explain over there. Next, what we have now, we will I will give the brief about it, then we will stop over here. That's the flow control and error control we have. So two stuff we have, like flow control and error control. What do you mean by flow control? Like we can say right now you are having some of the particular link is there, having some of the Mbps of the data. Let's take a 12 Mbps speed is there of your particular internet link. But from the transmitter side, data is generating from the 24 Mbps of the speed, but you are only able to get the speed of the 12 Mbps. So we can say that 12 Mbps is getting extra, is generating from transmitter side. So at that particular scenario, how this flow is going to be controlled, what are the different stops are there, what are the different techniques are there which will actually control this particular flow. That's the flow control technique. Similar, there is a error control techniques are there, like if it is going to be happen like that, you have transmitted one particular frame, but intermediate it get affected with the loss, and if it affected with the noise and wrong data you have received. Now once you have received the wrong data, how you can notify from the receiver side that I need a right bunch of the data. So for that also there are some of the techniques are there which will give you the notification like that, whatever the packet I have received, which is actually an error, which is containing the error. So I need a new packet for this particular frames, or I need a new frames for that particular data transmission. So such type of the technique is considered as a technique of error control technique. So this two technique we are going to be discussed in the next lecture, and that type of the what are the stuff are there, how it is going to be detect the different error, how it is detecting the different flow. There are one basic diagram is there. So how that diagram is going to be modified every time when we are advancing the technique in terms of flow control and error control. So that type of the stuff we have in the next lecture. So now, is there any doubt or any particular problem is there with this particular lecture? So you can tell me right now. Any doubt, any issue, please share with me. Everybody has written their name and the topic. Anyone who has left in this particular writing the topic, or who is absent today? Only 20 students are there. Who is absent? Bhavik, Bijraj, Jaimis, Jayesh, Jason, Kustu, Rahul, Rageshwari. 22. One extra has joined. Viren, Adit has joined. Yogesh, Rajkumar is there. Tahir is there. Jason is there. Soumya, where is Soumya? Yeah, Soumya is there. Then Bijraj is there. Who is absent today? I think no one is absent. Okay, whatever it is. So I think you have written topic name over here, and that topic you need to start preparing any type of the mode, whether it's a PPT or whether it's any type of the presentation technique. If you have still any doubt, you can ask the doubt right now. We will solve, because lots of topic we have discussed today. If you have any doubt over here or any other doubt in this subject, so you can discuss right now. Any doubt, any query? If you have not, then you can. Yes, Soumya.
સર આપણે તમે ઓલું ક્વેશ્ચન બેંક આખી અમને લખવાની કીધી છે છેલ્લે લગી.
ઓકે.
તો સર એમાં કંઈક વધારે ક્વેશ્ચન છે સર, તો એમાં બધી કંઈ
if it is a repeated, Soumya, if it is a repeated question, so you can write it only one time.
એટલે નહીં રિપીટેડ તો નથી, તો મેં હજી એટલું પ્રોપર જોયું નથી, પણ આ નંબર ઓફ ક્વેશ્ચન્સ જ બાટલા છે.
Okay. So what initially you need to do, like the topic which is mentioned to the higher time of the examination. Like कोई question है वो 5 से 6 बार वो पूछा गया है. If it is mentioned in the next column like that one, so you need to first write those questions. If it is asked only one time, so you can just kind of, not I can say steep, but you can put it as a last kind of the priority. But you need to first prepare those questions which are very famous in terms of the examiner. Is that okay? So first start writing in that way. If it is still going to be higher, then we will look out for that. But start preparing. At least whatever the question mentioned in the initial topic, up to 3 to 4 chapter, it must be written, every question. That's my personal advice to everyone. After the later on chapter, which is cryptography and other chapters are there, we can do the kind of the sort out in that one. But what you can do that, you open the syllabus and identify what is the overall weightage of that particular chapter. According to that, you can choose how much question I can write. Is that okay, Somya? It is not like that. आपको लिखना ही है, सब लिख के ही लेके आओ. No. If you can feel this is not going to be that much of the time asked in the GTU examination, you can skip those also. Okay. Or you can prefer that there is a question paper also available in the GTU website, or I will also upload the question paper in the Canvas for your reference. So you can sort out from that, like which question is asked most of the time. So first we will write those answers. Okay. Is it okay, Sobia? So it's applicable to everyone. Okay. So if you have not any doubt, any query, then you can leave. And goodbye, everyone. We will meet tomorrow with the topic of error control and flow control. Bye.